there is another set of relationships involving trigonometric functions. This is known as the law of cosines. So once again, we have our triangle, ABC and alpha, beta, gamma, all relative to each other. So A is across from alpha, B is across from beta, C is across from gamma. And here are the formulas. A squared equals B squared plus C squared minus 2BC cosine alpha. B squared equals A squared plus C squared minus 2AC cosine beta. And C squared equals A squared plus B squared minus 2AB cosine gamma. Now, even though these three equations look different, they all say the same relationship. So it turns out that this is related to the side angle side situation. We have two sides and the angle between them. So I'll just call this side, I'll just number side 1, side 2, and we have an angle. We'll call it theta, like this. If we have these three things, we can calculate the third side, and that's what this is saying in each case. So the two sides that are around, surrounding this angle here are the two letters here, so BC. A is the opposite side there, and alpha is the angle here. So if you always think of this in terms of the relative positions, think about encompassing the angle with all the information on this side is equal to that side. That's probably the easiest way to keep track of all these symbols here. Now, the law of cosines is sometimes called the generalized Pythagorean theorem. And so the question is, well, what does that mean? Let's take a look at this bottom one right here, except let's take the case where gamma is equal to 90 degrees. So our picture looks like this. Here's our gamma. Oops. That is our gamma in here. And then if we label the sides, so A, B, C is going to be across from gamma. And we look at the situation here, we see that, well, with the right triangle, it's A squared plus B squared equals C squared. And if we look at the law of cosines, if we were to set gamma equal to 90 degrees, cosine of 90 degrees is equal to 0, and so this whole term goes away, leaving us with C squared equals A squared plus B squared. In other words, the Pythagorean theorem. And so this is why this is sometimes called the generalized Pythagorean theorem, because the Pythagorean theorem is a special case of this. Here's an example. Solve the triangle. In this case, we have a side angle side configuration, so the known angle is trapped between two known sides. And so that tells us that we want to use the law of cosines here. And so what do we have? Well, let's make our chart first. A equals, B equals, C equals, alpha, beta, and gamma. Our only known angle here is gamma, which is 30 degrees. A is across from alpha, so that's 10. B is across from beta, so that's 12. And so we need to set ourselves up with the law of cosines version that has the two sides here, in this case the A and B, and the angle gamma all on the one side of the equation. So C squared is equal to A squared plus B squared minus 2AB cosine of gamma. At this point, it's just a matter of plugging things in. C squared is equal to 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 30 degrees. Now in this case, we actually know 30 degrees exactly. Even though later on, since we're going to take a square root, we're probably going to have to go to a calculator, we'll go ahead and leave it in exact form for now. So this is C squared is equal to 100 plus 144 minus 2 times 12 times 10, which is going to be 240, cosine of 30 degrees. So think about our unit circle diagram. Cosine of 30 degrees is root 3 over 2. C squared is equal to, let's see, that's going to be 244 minus the 2 cancel that part, 120 root 3. And then C is equal to the square root of this. Now, we don't need to worry about plus or minus here because we're not going to have any negative distances. And so again, as we suspected, at this point, we're still going to need a calculator. So when you plug it in, you're going to get about 6.013. Now at this point, we still need to figure out our alpha and our beta. And so what we're going to have to do is we're going to have to take this information and now plug it into the law of sines. And so these problems will require you to do both a law of sines and a law of cosines calculation. So sine of alpha over A equals sine of beta over B equals sine of gamma over C. Okay, so what do we have? We have our A and our B, we have our C, but we don't have alpha and beta. So I'm going to I'm going to pick the alpha value here, and let's work on that one. So sine of alpha over a, which is 10, is equal to sine of gamma, which is 30 degrees, over c, which is 6.013. Sine of alpha is going to be equal to, well, we do the calculation, 10 over 6.013 times sine of 30 degrees. Throw that into a calculator, and we're going to get that this is equal to 0.8315. Now, as always, our unit circle picture, we are trying to pick a value that has positive y, so we're going to have a value in the first quadrant and a value in the second quadrant. So the alpha value is going to be equal to either 56.2 degrees or it's going to be 123.8 degrees. Now here's an interesting question. Well, which one is it? Both of these cases, if you take them and try to plug them in, you will get a valid value for beta. However, the side angle side theorem says that there's only one triangle that satisfies these conditions. And so we have to have a mechanism for determining which one. And the easiest way to do that is to look at the largest side. The largest side should always be across from the largest angle. And so when we plug these in, we need to check what the value of beta is going to be. And if it satisfies that condition, that the largest side is across from the largest angle, everything should be okay. So let's see what happens. If we pick alpha to be 56.2 degrees, then beta is going to be something like, let's see, 56.2 plus 30. So this is going to be roughly 90 some odd degrees, which makes sense. If we take the 123 degree angle and add 30 to that, that's 153. There's only some 26-ish degrees or so left for beta, and that angle will no longer be the largest one. And so we can actually figure out which one it is by just paying attention to that heuristic. The largest angle will always be across from the largest side. So once we know what this one is, we can actually do the rest of the calculation to get that this one's 93.8 degrees. Right? The largest angle is across from the largest side. If we had it the other way around, that would not have been the case. And I'll go ahead and write it out here just so you can see it. So the alpha in that case would be 123.8 degrees. The gamma would be 30 degrees. And if you calculate the beta, it'll turn out that your beta is going to be 26.2 degrees. And if you look at the corresponding values, we now have the smallest angle across from the largest side, and that's not going to work. So that will be your heuristic to help you decide which configuration you want when using the law of cosines.